All right, this is section 6.3. We are going to learn another method of solving a system of equations. Just to review, a system of equations is two or more equations solved at the same time. And in our previous lesson, we learned how to solve by using substitution. This time we're going to solve by using elimination. Sometimes substitution is not the best method. If there's coefficients in front of the x and the y, you have to do a lot of rearranging of the terms. And so it gets to be kind of a burden. Also, maybe you get a really big fraction that you have to substitute in for another variable. You tend to make mistakes that way. So here's another option of solving a system besides graphing and substitution. Elimination is simply just another method, and you're going to eliminate one of the variables by adding both equations together. So the whole idea is to make one of the variables disappear. You can make the x disappear, or you can make the y disappear. Just like in substitution, you have choices. Your answer, again, is an ordered pair, or no solution, infinitely many. So it just depends on what you get. So the steps for elimination. You're going to make sure the variables, the equal sign, and the constants are lined up. So easiest way to do that is to put them in standard form. And if you line them up in standard form, you'd have your x number first, then your y value, and then it equals the constant. And so what's going to happen is you're going to have two equations written right underneath each other in standard form, just like that. So your x's line up, your y's line up, and your constants line up. It looks like one great big addition problem. You're going to look for common coefficients. So if you remember, the coefficient is the number in front of the variable. You're going to look for the variables that have like coefficients. So maybe a 2x and another 2x, or a 3y and a 3y. The sign may be different, and that's okay. Just look for the number part to match. Make sure the common coefficients have opposite signs. So you want them to be a positive 2x and a negative 2x so they cancel, or a positive 3y and a negative 3y, so that when you add these together, they will cancel. So if you need to, you may have to multiply one of the equations by -1 to force that opposite sign. And I'll show you that. We're going to add the equations. Okay, we're going to simply do good old-fashioned elementary addition of these two equations. So we will add the x values together. We'll add the y values together, and one of them will eliminate because of that common coefficient. So it'll eliminate one of the variables, and then we'll also add the coefficients together. So as long as we do this consistently, we're not breaking any rules. You're going to solve for the variable that's remaining, and then once you get that variable, you're going to plug it back in, use substitution to find the other. So you're going to add them together. One variable will go away. It'll eliminate, solve for the remaining variable, and then plug that number in to one of the original equations to find the other variable. So let's go ahead and try it. So if you look here, we have common coefficients. Everything's lined up nicely. You have your x's and your y's lining up. And I notice that I have a common coefficient 5. So I'm going to try to make my y values eliminate. And if you notice, if you look a little closer, they're already opposite signs. So we're good to go. So I'm going to simply just add these two together. 3x plus a 2x is 5x. A negative 5y and a positive 5y cancel. And then it equals negative 16 plus 31 is your 15. So notice that our x is remaining and our y value went away. We're going to divide each side by 5. X is equal to 3. We're not finished. Now that we have one of the variables, we can plug it into one of the original equations. Does not matter which one we use. And so I'm just going to take this bottom one right here. 2x plus 5y equals 31. I'm going to replace x, or substitute x, with 3. That gives me 6 plus 5y is equal to 31. And now we're going to solve for y. Subtract 6 from both sides. 5y is equal to 25. Divide both sides by 5, and y is equal to 5. So my solution is still the ordered pair, 3, 5. It still means where these two lines would cross if they were graphed. And they're both, so it's a solution to both. So you could plug in the x, plug in the y into each equation, and you'd know that you were correct. Let's try another one. Example 2 here. Example 2, I notice that I see a common 2 for my x values, a common coefficient 2. So if I add opposites, they will go away. I know we could subtract, but we're not going to subtract. We're actually going to multiply through by a -1, and that will take care of it. You guys, we always mess up our subtraction with positive and negatives, so this is going to fix that for us. So we're going to multiply both sides by -1 of one of the equations. So if we do 2x plus 5y equals 6, that's the first equation written over. And then the second equation, I'm going to multiply the entire equation by -1. And so that's going to make that a -2x, a -9y, and a -22. Now I could have planned ahead a little bit, and I could have done the first equation by -1 instead. It just makes your signs different. So now when I go ahead and add these two equations together, my x is going to cancel. 5y minus 9y are added together, you get a -4y, and that's going to equal a -16. Divide by -4, divide by -4, y is equal to 4. Now that I have my y value, I go back to the original problems and solve for the other variable. So I'm going to plug y back into one of the two. Doesn't matter which two. And so we do 2x plus 5y equals 6. That's the equation that I chose. I'm going to plug y in as 4. So I'm going to substitute y for 4. Plug it back in. Replace y with 4. 2x plus 20 equals 6. Subtract 20 from both sides. 2x is equal to -14. We're going to divide both sides by 2. X is equal to -7. So my solution for this system, make sure you put it in alphabetical order, -7 and +4. I'm going to show you one more. I know there's 2 more there. Let's go ahead and skip this next one. But we're going to actually do the following one. Change the variables a little bit. What's nice about systems is you can change variables. Maybe this is in reference to food, okay? Or maybe it's money, or maybe it's team names, maybe it's a person's name, Fred and George. So what's nice about algebra is you get to apply a name to the variable, or you can change the variable to match what you're talking about. It's not always an X and a Y. And so when that happens, when we write our answer, we follow the rules of the alphabet, and we always write our ordered pair in alphabetical order. So your answer is still an ordered pair, A, B, C, D, E, F, G. So F is going to come first, and then G. Okay? So a simple, I see that the 7s are matching. I got to do a quick little multiplication of -1 on both sides. Multiply both sides by -1. So I'm going to get 7f plus 3g equals -6. That's the first equation. The second equation becomes -7f plus 2g equals +31 now. Don't forget to apply the -1 to the other side as well. We're multiplying both sides by -1. And then we add these two together. The f's cancel. I get 5g is equal to 25. Divide by 5, divide by 5. G is equal to 5. Go back through and substitute in. So I'm going to substitute G into the first equation. I like to draw my arrows. So I'm going to rewrite my first equation. 7f plus 3g equals negative 6. Substitute the 5 in for g. 3 times 5 is 15, so I have 7f plus 15 equals 6. And solve. Subtract 15 from both sides. 7f is equal to a negative, oops, I dropped my negative here, negative 21. Divide by 7, divide by 7. F is equal to negative 3. So my solution is F first, which is negative 3, then your G, 5. Negative 3, 5. All right. So if you want to do the above example for some extra practice, we'd be happy to correct that for you. We're now at that point where you're going to do a lesson summary, and then go ahead and finish your lesson summary, and your practice problem for the night is 2x plus 5y equals 6, and 2x plus 9y is equal to 22. Good luck.